Hello students, in this session I am going to discuss the next topic of your operating system, which is process scheduling. So we have already discussed what is program and what is a process. So I am not going to explain that again. So we have discussed what is a process and what is a program. Now coming for process scheduling. Before going to process scheduling, we need to understand what is the use of process scheduling. So we have discussed different types of operating system. When you have different types of operating system, under that we have discussed one type of operating system called as multi-programmed operating system. So multi-programmed operating system is an operating system where in your memory, that is RAM, we can store more than one process. From that, any one process will be sent for execution. So that is how we'll be using something called as scheduling. You can just consider an example, like say you have multiple buses for a place. Say I have a place like some Bangalore to Delhi or something like that. We have two different places. Now if I have transportation, we'll have something called as schedule or timetable. What does that mean is, from that particular city, from Bangalore to Delhi, how much buses are there, how many buses are there, at what time. So that will be referring something like scheduling of that particular transportation. Similarly, when you consider your process also, when you have multiple process, you have more than one program to be executed, those programs are stored into the RAM. From the RAM, any one program will be selected by something called process manager. We have something called as process manager. Okay, so what is the use of process manager? As process manager is responsible for selecting one, say for example, if I'm executing one process, so I'll stop that process and I'll store that process and I'll go for the next process, which is important. Okay, so maybe because of some input or because of some resources required or some problem, we'll switch from one process to other process. That function is taken care by process manager. So process manager will be responsible for, we will consider it as switching of process. Okay, so in general, if you have two programs running at the same time, actually it will not be running two programs. That is, if you have a single CPU, if you have a single processor or one core processor, in that processor you can run only one process at a time. Now you can run one process, if you are able to run only one process at a time, if one process is running, other process will be waiting. So when this process completes, or if this goes for some input output or other kind of functions, then the other process will be selected for execution. This is nothing but switching. So it is just like if you have one chair or something, if one person is sitting there, if I want to make some other person to sit there, so first the person who is sitting should get up and then the other person will be seated there. Similarly, so you have something like that, we'll consider as switching of process, which is taken care by process manager. Okay, so in this, so which is called as your process scheduling. So and that we'll be studying something called as scheduling queue. So we'll be starting with this diagram, with the help of this diagram, what is scheduling queue. So I'll explain what are these first. Whatever things that you are going to see in a square, these are called as queue. Okay, a rectangular box, whatever you are seeing, that is the queue. Queue in the sense, it is a memory location. Okay, just understand it is a memory location where the process will be stored. Okay, and whatever you are going to see in the form of circle, these are called as resources. Okay, so resources in the sense, the devices, it can be input device, it can be output device, or it can be a any kind of process or something like that. It can be any resource. So whatever that is you are going to see in the form of rectangle, it will be acting as a queue, and whatever you are going to see in the form of circle, it will be acting as a resource. So if that is clear, next we'll go to the next topic, or next thing is, say for example, I have two programs. I have MS Word and MS Excel have started two programs, or I want to execute MS Word and MS Excel, both the softwares I need to execute. When this has to be executed, in the RAM, I am going to store Excel related programs and Word related programs also. So this is, once this program will be loaded onto your RAM, this will convert into your process that we have discussed. Okay. Now we'll have operating system, we'll have MS Word as well as MS Excel. Now all these things will be in the ready queue. A ready queue in the sense, this queue contains the program or process which is waiting for CPU. As I told you, CPU can execute only one process at a time. Only one process at a time it can execute. It cannot execute two programs at a time. So it cannot execute two processes at a time. It can execute only one process at a time. In that case, all these three processes will be in ready queue. Now, once CPU selects MS Word for execution, then CPU will be executing MS Word. Okay. Now, while executing MS Word, there may be several functions. Like, first one is IO request. Say for example, in MS Word, I want to add an image. I want to add an image into the MS Word file. In that case, I need to go to hard disk or your memory device where I store the image. So this is nothing but I am accessing some information. I am taking some input from memory device. In that case, from MS Word, from CPU, it will come to IO request. So it is requesting for some input value. So from input value, it will go to input IO queue. From there, it is going to access the resources, which is your hard disk. And from hard disk, it is going to take the function, and whatever input it needs, it will take the function and it will come back to ready queue again. Okay. In the sense, when any process needs input output, any input output function, it can be an image, it can be a keyboard input, it can be a camera, it can be a printer or something like that. So it will be having something like this. So once a process is executed by the CPU, if the process needs any input output functions or any files to be read or any output to be printed, it will come to IO request. From IO request, it will go to IO queue. From there, it will access the resource. I can also consider printer. Say for example, I want to print the information that is present in Word. Then I will go to IO request. I will be requesting for what? I will be requesting for printer. If printer is available, it will be sent to printer queue. Printer may have many printing files. In that, my file will be one file. Then after that, it will print the value or print that particular sheet of paper. After that, again it will come back to ready queue. That is MS Word, once it has printed completely, it will come back to ready queue. Again, second scenario is time slice. Time slice is, for example, if you consider you are going to get a option like when you have given some information. Say for example, you have any software and you have clicked some function there. You have clicked on close, minimize or maximize, and it will give you some information like not responding. After some time of waiting, it will give you information like not responding. So in the sense, the processor will wait until some time so that the process is going to execute. Whenever a process is not executed for some time, it will cut nothing but we have given some 2 milliseconds or 5 seconds or 10 seconds for execution of this process. If the process has not executed, then the time has expired. In that case, it will come back to ready queue again. Understanding? After waiting for some time, if the process has not executed or the user terminates the process on his own, like we'll go to taskbar and we'll close the process. In that case, we'll forcefully terminating that particular process. So that kind of case will be the second scenario where after waiting for few time, if the process is not executed, we're going to take it to ready queue. You can also consider one more example, like when you're accessing your bank, like internet banking. When you're accessing internet banking, it will wait for few seconds after logging in. If you are not given any response, it will just log out because you have not given any response there. So once the time has been finished, the process will stop and it will come back to ready queue again. Okay. Next is fork. Fork is nothing but we'll consider it as sub process, or it is also considered as child process. Okay. So for any program, we'll have sub processes, sub programs that has to be run. Example, if you consider MS Word, for example, you can consider checking of spellings, like it will be underlined, or checking of grammars, and you have many other functions. Like once you type a few lines, it will be getting the number of count, like how many words has been added, how many letters has been added. All those are sub background processes. So those background processes will be created based on your request. So whenever any process is executing, the process may stop its execution whenever you request for sub process to execute. Okay. And after that, we'll consider the last scenario is, it is called as interrupt. It is called as interrupt. Okay. So what is interrupt in the sense? Say for example, you are using the same software. I'll be using MS Word itself. You have plugged in a pen drive. When you plug in a pen drive, you'll get a message saying that a new device has been detected, USB device, open the file or something like that, that kind of information. That is nothing but whatever word you have executing, it has stopped because there's an interrupt saying that a new device has been detected, and that particular process which will be displaying the information of that device will be, you can see it on the window. That is, whenever you are executing MS Word, if you are doing any other function like connecting a pen drive or removing a pen drive or something like that, so whenever you do some action like that, that action will be given preference and that will be executed, after which your current process will be executing. So what are these in the sense? Whenever you are executing one process from the CPU, if you want to take out this process, these may be some of the chances. Like whenever you request for any input or output function, then Word will be removed from CPU. Whenever you are not using Word for 5 or 10 minutes, that will be removed from CPU. Whenever you are creating a new sub process, whenever sub process is created, like you are going to connect your MS Word for mail merge or something like that. Whenever you are doing that, this word will be removed from CPU. And interrupt, whenever you connect a pen drive or something like that, then word will be removed from CPU, according to which whenever this will be removed, other process will be loaded onto the CPU, so where it will be executed. So this process is considered as process scheduling, and we have discussed what is scheduling queue. Okay, so this is about what is scheduling queue. I'll continue with the next topic. Since I need to draw one more diagram, I'll draw it in the next session. Coming for the next topic is schedulers. Schedulers, as I told you, we have discussed. Scheduler is nothing but a process of selecting any program or given process for execution. So from the list of jobs or from the list of processes, if we select one process for execution, that is like your schedulers. So the scheduler will be having, we're going to divide into three types: long-term scheduler, medium-term scheduler, as well as short-term scheduler. As you can see in the in this given diagram, so we are going to divide this scheduler into these three types: long-term, short-term, as well as medium-term. Okay. Now, what is long-term scheduler is? Long-term scheduler's function is, it is going to select a job, or it is going to select the process which will be having balanced functions in terms of both IO as well as CPU requirement. For any program or for any process to execute, it needs basic resources like input, output, as well as CPU. CPU is the one who will be executing the process, and for executing that process, if you need any input and if you want to print any output, we will be using IO. Okay. Now, this long-term scheduler's function is to select the process which will be having balanced number of input output functions as well as CPU functions. In the sense, we have two different types of processes, like One is like IO bound, and other one is, we'll consider it as CPU bound. Okay, so the processor can also be, we're going to consider the processor like IO bound as well as CPU bound. What does that mean is, if any process is spending more time on input output, for example, if we consider an audio player, or like say your movie or something like that. If you consider a movie is a like say it is a process, or it is a like your VLC player, it is a process that will be mainly concentrating on input and output. In the sense, it is having only one thing, like it is going to read the data from your movie file, and it is going to give the output onto your monitor and also speaker. So it is having major part in terms of IO bound, input and output. CPU bound is like, for example, consider your antivirus or something like that. It is not going to have more of input or more of output. It will be checking your files, and it will be more time will be spent in the CPU. So CPUs will be accessing that particular process more compared to that of input output. So any process that you are going to select, or whenever you click on any given event, that process will be loaded onto the RAM, and from RAM, when it is selected for the queue, this long-term scheduler is going to see that the number of process which will be used for IO bound and the number of process which will be CPU bound will be selected like even. Okay, it will be even number of IO devices, IO bound process, and even number of CPU bound process will be selected for execution. So that is what is the use of long-term scheduler. Now medium-term scheduler is, its simple function is to switch. To switch in the sense, from the given say for example, from the given process which is executing, it will stop the current process and it will switch to other process. This type of switching from one process to other process, that type of scheduler will consider as a medium-term scheduler. And at last, short-term scheduler. Short-term scheduler, its function is just to select one process from the ready queue, and it will be sent to the CPU. So this is called as, like say, long-term scheduler, which is considered as job scheduler also. Medium scheduler, which will be like which will be used for swapping. And short-term scheduler is considered as CPU scheduler, because it is going to just give one process for execution to the CPU. So from ready queue, it is going to select one process and it will give it to the CPU for execution, which is the job of short-term scheduler. So we have three types of schedulers: long-term, medium-term, as well as short-term. Long-term is a scheduler which is going to select the process for execution. When it is selecting a process for execution, it is going to see that number of IO bound process and number of CPU bound process are similar, or number of count will be similar, or it will be equal. And medium term is, it is going to just any process under execution which has stopped, or due to some function interrupt, it has stopped, in the sense it is going to switch that out and it is going to select the other process. That is going to be select that out of the CPU, which is medium term. And coming for short term, it is going to just load some process onto the CPU from the ready queue. So that is why that is called as CPU scheduler. When I say CPU scheduler, it is nothing but short term scheduler. Job scheduler is long term scheduler, and swapping is nothing but it is done by your medium term scheduler. Based on this, we have one more concept called as context switching, that also we will discuss in the next session. Thank you.